Geometry 1, Chapter 4 test, Topic 7. You should be able to identify rotational symmetry and the degrees of rotation. So the example, identify if the following shapes have rotational symmetry and, if so, the degrees of rotation. So what you're looking for with rotational symmetry is some sort of repetition in the shape. So here, this first shape, kind of like a cloud, we're looking for something that appears multiple times, something kind of distinguishable that if we turned the picture would end up back on top of itself. So here I noticed this part right here. It's kind of a part of the cloud that sticks in a little bit further. So if we started to turn this cloud, that piece would have to have some place to end up if there was rotational symmetry. So look around, are there any more pieces that kind of stick out that far? And the answer is no. So the only way to get this piece right here that's extra long back to itself is essentially to go all the way around the circle, which would be 360 degrees. And anything over 180 degrees basically means there's no rotational symmetry. So, does it have rotational symmetry? No. The second shape. Let's focus on, I don't know, let's call that point A. Now, if we started to turn this shape, point A, let's say we were turning it clockwise, would go this way and go up and around, and it'd end up over here, except the issue is that in the top right corner, there is no corner. It's been cut off. It's at a slant. So A doesn't have a place to go there. But if we kept turning it, A could go all the way around and end up back here, let's say at point B. They're both points. Well, that's halfway around the circle. So if the entire circle is 360 degrees, halfway around the circle is 180 degrees. That's the first time that this shape is going to end up back mapping onto itself. And that's good because if you notice here, the straight edge in the top right, if we were to rotate this halfway around, it would end up over here on the bottom left. That's good. It means that this shape has enough symmetry that we can in fact rotate it. So the answer is yes. The number of degrees is halfway around the circle, so that's 360 divided by 2, which is 180 degrees. Now the third picture, we kind of have this square inside of a square. So again, we can use a similar idea as the last shape. If we focus on the top left corner, maybe call it A, and we start to turn it. Well, if we turn this picture, A, the top left corner, look, there's a top right corner for it to end up at, point B. But then we could keep turning it, and there's a bottom right corner for it to end up at also. That's point C. Now you could, in theory, keep turning and bring it all the way around to point D, the fourth corner. Except when it comes to rotational symmetry, anything over 180 degrees, we don't count. We only go from 0 degrees means no rotation at all, so we don't count 0. We only count up to 180. So there are 2 turns before we get halfway around our shape, and then we stop. We've made it halfway. So yes, there is rotational symmetry. If we took, here's an example, if we took that shape and we turned it like this, it looks exactly the same as it did when we started. We could then take it and turn it again, and it's also the same shape. Oftentimes, all I do is actually take my paper and rotate it. Does it look the same? Does it look different? So the question is the number of degrees. Well, off to the side here, a full circle is 360 degrees. How many times would it take to rotate A to get it back all the way around the circle to A? Well, you would go A to B, B to C, C to D, and D to A. It would take 4 rotations. So you take 360 and you divide by 4. What that means is that each rotation is 90 degrees. So from A to B is a 90-degree rotation. From B to C is a 90-degree rotation. So to get from A to B, that's 90 degrees. But then we don't write 90 degrees again because we're not actually trying to rotate from B to C. We're trying to rotate from A to C. Well, A to B is 90 and B to C is 90, so A to C is 90 followed by another 90, 90 plus 90, 180 degrees.